Section 6-3, number 27, gives us the equation y is equal to 7 times the quantity 2 minus 0.9 to the x power as a function of lava flowing from a volcano, where x is the number of hours since the lava started flowing and y is the velocity of the lava. Part A asks us to find the derivative of this equation and then to find the speed of the lava at 0, 1, 5, and 10 hours. When you take the derivative of the original problem, you get 7 times negative 0.9 to the x power times the natural log of 0.9. By plugging in the x values from this question, we get decreasing velocities as time passes. This means that the lava is slowing down as time passes. Part B asks us to transform the original equation so that x is in terms of y. To do this, we first divided both sides by 7. We then added 2 to both sides and multiplied by negative 1. We then took the log base 0.9 from both sides to get x is equal to log base 0.9 of 2 minus y over 7. We can then use log properties to get x equals the natural log of 2 minus y over 7 all over the natural log of 0.9.
For part C, in number 27, it's asking you to differentiate part B. And then after that, you have to calculate dx over dy when y equals 10 miles. And finally, it asks you what is the units of this problem. So in part B, you got ln of 2 minus y over 7 divided by ln of 0.9 equals x. This can also be written as x equals 1 over ln of 0.9 times ln of 2 minus y over 7. Because 1 over ln of 0.9 is a constant, we can solve this just to be as negative 9.49122. Now we have to differentiate ln of 2 minus y over 7. So what we did here is the first portion of ln of 2 minus y over 7 is equal to 1 minus 2 minus y over 7. Then you have to multiply, using the chain rule, you have to multiply the whole equation by negative 1 over 7. After you solve all this out, the negative 1 times negative 1 is obviously, negative 1 times 1 is obviously negative 1, but then you have 2 times 7, which gives you 14, and then you have y over 7 times 7, which just gives you y. Finally, for the last step, you're from your constant, negative 9.49122, multiplied by this portion here, negative 1 over 14 minus y. These two together give you 9.49122 over 14 minus y. And this is your dx over dy. After you find your equation, you have to plug in 10 for your y value. So you're giving 9.49122 over 14 minus 10. This then gives you the value of 2.37281, and the units for this problem is in hours per miles. Now, for part D, it's given, says, calculate dx over dy for the value of y when x is equal to 10 hours. Now, x is only in hours for your original equation of y minus 7 times 2 minus 0.9 to the x power. So what we do here is we plug in your x value of 10, and when you do that, you're given a value of y equals 11.5593. You then have to plug this value back into your dx over dy equation, so you're given 9.49122 over 14 minus 11.5593. The final value you're given is 3.8865 hours per mile. Part E, the final question in problem 27, says you might think that dy over dx and dx over dy are reciprocals of each other. Based on your answer above, in what way is this reasoning true and in what way is it not? So if we go back to the beginning, when x is equal to 10 and we plug in for our dy over dx value, we're given 0.257159. The reciprocal of this is 3.8865. This is the answer that we also received in part D. But then again, if we go back, we do this 1 over 3.8865, we see that it's also equal to 0.257159. Now, when y is equal to 10, dx over dy is 2.37281. This is not the same for when y is for the dy over dx value. So what we can say is that dx over dy and dy over dx are reciprocals when x equals 10, but not when y is equal to 10.